a lot of people have been wanting me to talk through question 7 of the assignment, but I mean, it doesn't really make too much sense without talking through question 6 as well. So we're going to quickly cover question 6, which is just using indifferent curves and a feasible set to show about free time and grades, and then we'll get on to this steepness part, which I know lots of people struggled with. So what we're going to do is we're going to do our axes. Oh, that's very wonky, but you're getting at the gist. And let's put grades or final grade on the y-axis, and then we're going to put free time here on the x-axis, and it's going to be hours. Maybe I should make that clear. Hours. Okie dokie. So reasonably 0, 0, because the fewest amount of free hours I can have is 0, and the lowest my final grade can become is 0, hopefully, providing there's no negative marking. Let's pretend our final grade is a percentage, so let's say it's out of 100, yeah? And the maximum amount of hours I can have for 3 hours is 24, so let's say I took the whole day as my free time, and the maximum grade I can get is 100. Okie dokie. Now, in the core textbook, they actually draw your feasible frontier or your production possibility frontier, whatever one you remember it as. They actually drew it from 90 to 24. I don't particularly like that very much, purely because it means that no matter how much time I put into studying, it's telling me I can't get 100%. Let's be optimistic and let's say I can get that. So we're going to do it here. Oh, that was really wonky. Let me rub that out and try that again. But I'm sure you get the gist because you guys were really good with this question. So free time to there, and you know what? Make my life easier. Let's move the 24 marker. Let's move it so it's there. So let's say that was 24. Okie dokie. So this is saying that if I had 0 free time, so I spent all of my hours studying, then I'd get 100% on my final. It doesn't really matter what number you pick here, right? It's just showing that you get the gist. And if I spent all of my time of the day having free time, so leisure time, then I'd get 0 on my exam paper. Yeah, you could argue whether or not you think this is reasonable or not, because you could say, well, hang on a minute, maybe I don't need to do any studying and I'll at least get something. And similarly, you could say, well, I might be able to spend all of my time studying, but I might still make a mistake and not get 100. Yeah, you could make those arguments, but this is just get the idea that you understand that what a feasible set is. We can't really go beyond this. Okie dokie, so that's the feasible set part of the diagram, which is here. So anything within it or on the line is what's possible. And then we need to do an indifference curve. So indifference curves. You get your general downward sloping indifference curves. So let's just draw one looking like this for the minute. We could have this as an option. But the thing with this is this isn't our most optimal indifference curve. Let's call this IC1. Now, remember, the slope of the indifference curve, so slope of an indifference curve, is what's known as MRS, the marginal rate of substitution, and the slope of the feasible set, I'm going to call it FS for laziness, is MRT, the marginal rate of transformation, I think. That's what we call it here. Yeah. MRS and MRT. Okay, well, we prefer the highest possible indifference curve. Well, when is that a possibility? Well, the highest possible indifference curve that we could get is when it is tangential to the feasible set. So let me just draw that on here. Does it stop drawing? No. Oh, stop drawing. Oh, one sec. Sorry, let me rub that and draw that again, because that's not tangential, because it shouldn't cross it. Okay, IC2, you get my gist there. So the point at which we've got the most optimal indifference curve is when they're tangential. Well, the point at which they're tangential, which is here, our slopes are the same. The slope of the indifference curve at this point is the same as the slope of the feasible set, so MRS is equal to MT, and that's an optimality condition. So what we've shown here is we've shown our feasible set, we've shown our indifference curves, and then we've shown the point at where we're optimal. Okay, now, talking about these indifference curves for a bit, because we want to try and move on to this bit to do with steepness that I know a few people found a little bit tricky. Now, I've just drawn these indifference curves arbitrarily. I could have drawn them slightly different. Maybe I'll use a green colour. Let me see if that's going to work. So I drew it looking like this, but I could have drawn it shallower. I could have drawn this, let's take this IC1, I could have drawn it shallower, and I could have drawn it like that. So that's a shallower indifference curve. So I'm going to call that IC1 star. So it's a shallower indifference curve. Again, this isn't optimal. Where this would be optimal is where this indifference curve is tangential to this feasible set. Well, if I kept pulling this indifference curve this way, so let's pretend the shape of it stays the same. Let's say I can pick it up and move it, and the shape of it stays the same. What you'll see is it would end up being tangential. It would end up being tangential. If I can try and get it, it's a bit difficult drawing on this. This isn't the best drawing pad. It'll be tangential. Why is this not drawing? Maybe like that. So this should go further up. It's not letting me because it's cutting off the screen. But if I had this exact same shape and I pulled it up and saw the point when it was tangential, it would probably be tangential about here, yeah? Okay, so I've got this green indifference curve, which is shallower than the blue curve, so the blue curve is steeper, but to really hit my point home, I'm going to draw a third indifference curve in, one of a different colour, and I'm going to make it even steeper than this blue line. So let me draw another one in and make it even steeper. So something like that. Okay, well, again, this isn't optimal, okay? This will be optimal if I were to drag it outwards, but keep it the same and see where it's tangential to the black line. Well, if I were to do that, roughly speaking, it would look like that, and it would be tangential here. So, what have we got going on here from the green and the red? Let's have a look what we've got. So let's talk about green first. Get rid of that. Green. So green, remember, green was the shallower one. Green was our shallower one. It was less steep. What happened? Where did it cross? Well, let's call this point, let me call this point A. So it crossed at point A. Not crossed, it was, that's terrible. It was MRT, MRS equaled MRT at A. Okie dokie, let's go back to the red one then. So red was steeper. And we found out that MRS was equal to MRT at, let's call this point B, at B. So to answer this question really, all you need to do is you need to compare what's the differences between A and B. So in words then, let's go back to A, comparing A and B. For the shallower one, as soon as our indifferent curves is shallower, it's tangential higher up on the feasible set. Higher up on the feasible set, because it's not letting me write down here. Okay, and what about red then? It's tangential lower on feasible set. So we've got it higher up on feasible set, and we've got it lower on the feasible set. Well, let's talk about this then. So it's higher up, it's up here. What does that mean? Well, it means that I've got smaller, that's what I'm after, a smaller amount of free time, but a higher amount of final grade. So what does this mean? Well, this means I care relatively less about my free time, but relatively more about my grade. So for the shallower indifference curve, I care relatively less about my free time, but relatively more about my grade. But for the red curve, as we can see, because it's hitting its tangential lower down on my feasible set, it's when my free time is higher and my lower grade is lower. So what does that mean? Well, it's the opposite. I care relatively more about my free time, but relatively less about my final grade. So that's what we were trying to get at with the shallower and the steeper thing. And if I don't give you any more information, any indifference curves you draw are just arbitrary indifference curves. So when we first drew the blue one, fine, it's an indifference curve, but what's to say that it's that shape? What's to say it's not shallower like the green one, or it's not steeper like the red one? And that's where this question was getting at. So I hope that helps, that makes a little bit more sense.